In this video, we'll investigate the graph of I of S and ask what happens over time. So here is the equation plugged into Desmos. We have renamed gamma divided by R to K because Desmos can't, to my knowledge, display Greek letters, and also because gamma and R are both constants, so is their quotient. Desmos is being a little uncooperative. It shouldn't be displaying anything in the fourth quadrant because I can't be negative, but just ignore that. At the moment, I sub 0 is set to 100. S sub 0 is set to 2000. And gamma over R, which we're calling K, is set to 1000. And now we'll try to make sense of this graph. What happens as time passes? Well, time doesn't explicitly appear anywhere, but S, the number of people in the susceptible category, is always decreasing. That's a feature of the model. So at time 0, S is as large as it can possibly be, which is at 2000 over here. As time passes, S decreases, and we trace left along this curve. The epidemic takes off. Here it reaches its worst moment with about 406 people simultaneously infected. Then it tapers off. The SIR model predicts that epidemics end when there are no more infected people, not when there are no more susceptible people. That is, we hit the S-axis before the I-axis, about 346 of the initially susceptible people never did get sick. Now let's change these parameters. We'll increase this parameter K and observe that the larger K gets, the fewer people are infected. This makes sense. It is a ratio of the removal and infection rates. So if people are being removed quickly and therefore not infecting other people, of course the disease won't amount to much. When k reaches s sub 0, there's no epidemic at all. The number of infected people decreases monotonically until it vanishes. So if k is less than s sub 0, some form of epidemic occurs. Epidemic isn't a mathematically formally defined term, but I'm using it to mean that the number of infected people initially increases. However, we might not have much control over k. These are disease parameters. Let's set our parameter k back to 1,000. Another way to think of things is to let k be fixed and decrease s sub 0. The fewer susceptible people there are, the more mild the epidemic. And if we can get s sub 0 below the k threshold, there is no epidemic at all. The reason we might want to think about things this way is that if we can't control k, we might be able to control s sub 0. That's what vaccinations are for, to reduce the number of susceptible individuals below a critical threshold, and therefore prevent the disease from getting underway. If the number of susceptible individuals is small enough that epidemics can't take hold, we say we have herd immunity. Well, I'm obviously not going to turn this into a poli-sci class, but I simply can't resist mentioning England's response to the COVID-19 outbreak. It's so relevant to the material we just covered. Near the start of the epidemic, the English government announced a truly astonishing plan to deal with COVID-19. They were going to let their citizens get sick intentionally. Their reasoning was that COVID-19 mostly produces mild symptoms in people under 40. They'd let these people get sick, they'd recover without many people dying, and this would decrease the number of susceptible people enough that herd immunity would form. Well, everything was wrong with this. Heaven knows how they thought they were going to restrict the disease to young people. Herd immunity usually requires something like 90% of the population to not be susceptible, and they didn't have close to enough hospitals or medical staff to handle the influx that this would have caused. But from a modeling point of view, it was especially ridiculous because herd immunity is a product of the SIR model. You need that removed phase or it doesn't work. And we still don't know whether COVID-19 actually provides immunity upon recovery. If they're going to use models to investigate real world problems, that's good, but you have to be sure that the model you're using is appropriate. Thankfully, the English government has since backed off of that plan.